Let's go on a trip in which we look at Earth's geologic history. Earth has a very interesting history. Our planet has been through so many changes over time. And remember, our planet is 4.6 billion years old. Now, happy birthday, Earth. How do we know that Earth is 4.6 billion years old? Well, remember what we said about radiometric dating? We have performed radiometric tests on various meteorites and even moon rocks, and those tell us that the rest of the solar system is 4.6 billion years old. So is Earth. The planet changed over and over again, and scientists today still are looking at evidence of change. At one point, scientists believed that all geologic change happened fast. Earthquakes, volcanic eruptions, asteroids. They believed that the main Earth changes were happening very quickly. Another group decided that the geologic changes were happening at a slower rate, and the geologic processes that we were seeing today were the same that were happening in history in the past. We know today that it's a mix. While there are slow changes like erosion and deposition, there are also very quick changes like earthquakes and volcanic eruptions. So, how do you divide up 4.6 billion years? Well, the largest division of time is an eon. An eon is then made up of an era. An era is made up of individual periods. And then periods are divided up into even smaller times called epochs. The divisions of time are not always equal in how they are set up. For example, the Precambrian time was incredibly long compared to the Paleozoic era, the Mesozoic era, and the Cenozoic era. Many of the divisions in these time periods and eras are based on Earth's geologic history, and even some biological events like mass extinctions. Mass extinctions can happen for a variety of reasons, but I think I'm getting ahead of myself here. Let's start at the very beginning. That would be the Precambrian time. This occurred from 4.6 billion years ago to about 542 million years ago. So there's 3 eons within this time. When the Earth formed 4.6 billion years ago, it was under a great amount of pressure. The gravitational force that was pulling the material together to build the planet allowed for a tremendous amount of heat to build up as well. So these molten materials were moving together, and accretion is when they actually formed into the spherical planet that we have. The planet also sorted itself by the most dense material going towards the middle and the least dense materials going towards the outer parts. This is called differentiation. During the Precambrian time period, the molten rock cooled and continents started to form. The surface of the planet was still in motion, and there was tectonic movement still happening. This is where we have evidence of the earliest life forms, from early algae and bacteria to jellyfish and small aquatic organisms. Meanwhile, the atmosphere was also changing during this time. The volcanic eruptions, the water vapor, and even cyanobacteria releasing oxygen through photosynthesis changed the atmosphere. While the Precambrian time period was pretty cool, a better time period is on the way. That is the Paleozoic era. The Paleozoic era extended from about 520 million years ago to 250 million years ago. And this is where the term Pangea comes up. At this time, our planet had a global supercontinent. We had movement within these continental pieces, the climate was changing, and this is when we see evidence of a huge explosion in life and diversity. For a while. This era ended with a mass extinction. Anywhere between 90 to 95% of the marine animals died, and 70% of land organisms died. The Paleozoic era led into the Mesozoic era. This lasted from about 250 million years ago to 65 million years ago, and this is the age of the dinosaurs. Mammals were pretty insignificant at this time. This is when we find Pangea splitting up, North and South America separating, but at the same time we had mountain building, the mid-Atlantic ridge was forming. This time period was ended with an asteroid. Now we move into the Cenozoic era. This is from 65 million years ago to today. So some of the major geologic events during this time period would be the Indian subcontinent moving into Eurasia. This movement created the Himalayan mountains. Africa and Europe collision created the Alps. Our warmer climate went through a colder section. This is where we saw ice age and polar caps forming. And this is when we have the evolution of the modern humans. With all the amazing geologic and biologic events to have occurred on our little planet, it's amazing to think, what does the future hold? What geologic events are to come? What biologic events are going to happen? This is a dynamic planet. It is always building itself up, tearing itself down, and reinventing itself.